What are the most promising technologies that might enable net zero skyscrapers in the future? And do you think a net zero skyscraper is even really an attainable goal, energy-wise?
It's a good, yeah, I mean, it's a good question. And, you know, I think net zero is a very interesting challenge. And I think that we can talk about the operational side of the tall building, and then we can talk about the construction side, meaning the embodied energy that goes into tall buildings. And that's one of the things that we focused on this morning, actually, and there was a great dialogue about the life of a building, right? And the idea that it's far beyond just how we operate them and how we want to impact the environment. We need to think about during its, let's say, its service life. We need to think about the conditions where that building sits. Could be external forces, could be issues of the environment that these buildings could be subjected to. And I think considerations for embodied energy that goes into these buildings on the front side as we build and design is going to be far more important in the long run. In fact, many of these buildings that when we look at energy, sometimes it takes 20 years for the operational carbon that's in these structures to equate to the carbon that we put into these structures in the beginning. So if we lose track of the beginning, then the idea of net zero and the operation of these buildings and energy during its useful life may not be even as important as that initial construction. So I think that's something that community is really starting to get focused on, and that leads to more advanced ideas in performance, structural engineering, components within the structure that behave in a way that are smart, exterior wall systems that are smart, perhaps systems that look at very long lifespans, maintenance, systems that can be replaced over time and that sort of thing. So I think it's a very important part of what we're doing. And then take that idea and insert it into the city, what it means to the city, because we're planning very large cities around the world right now that could use that higher level of science as we kind of go forward. So anyway, it's perhaps an indirect response to the question, but I think it brings in these other ideas that add to it.
Well, the point about embodied energy is interesting because, especially extrapolating to the city scale, if you have a smart city energy efficiency-wise, you might not necessarily have a sustainable city if you're not looking at growth, what the area of land is, all these other inputs, material use,
right,
resource extraction.
Yeah, exactly. And the idea of greater density is something that's, I think, really important to cities, and how we think about that density and plan for it. And it's, it comes down to efficiency of space, right? Usable space, and how do we get at materials that give us less structure in terms of the floor plan, smaller exterior wall systems that are very efficient, that allow for greater use. And then this idea of material and planning cities that use more advanced materials, whether it's zero cement concrete, right? The elimination of that perhaps is an avenue. The use and reuse of material from other places, like steel being taken from and categorized and then reused, not just reconfigured and melted into another steel shape, but actually physically taking those steel shapes and moving them into new structures. I mean, that's all part of what I think is important for us to think about as we plan these big cities.
What role do structural engineers play in that, especially when it comes to recycling materials, or is that sourced at a different design phase?
Yeah, it's a really interesting question. I think 7 or 8 years ago we started to think about this a lot. And at first, when we started trying to address the issues of the environment from a structural engineering perspective, people were saying, well, it doesn't make any sense, right? You're really responsible for the safety of buildings, right? The constructability of buildings, and how does the environment get into that equation, right? Well, it's a really important part of it, because as you optimize your systems and look at new materials, you're able to reduce the impact of those buildings. and you're able to perhaps even get these ideas into a place where the public is aware of it, and perhaps into policy. So in designing structures, there might be a requirement that that touches on environmental issues, not just safety issues, for instance. And it's tied to greater performance, in areas of high seismicity and how we protect these buildings. It could be perhaps the use of wood in taller buildings, right?
Yeah, we were just talking about wood earlier, but I'm glad you brought up seismicity, because I wanted to ask you what tall building designers and engineers need to do to improve disaster resilience or climate resilience.
The thing that comes to mind, I suppose, is seismicity is one. There could be impacts of climate change and issues of change of water conditions and so forth, and tsunamis and things like that we've seen recently. But if we stick with seismicity, I think that the idea is to increase resilience of our structures so that, number one, they're protected. So in an event, perhaps an event that we don't expect, the buildings perform in a way that they can be put back into service. Number two, that we can get back into our buildings as quickly as possible. Right? So there's a big event. What we find in these big events is probably most important to shelter in place, to have people in buildings and not removed from buildings. And then there's the issue of business interruption. So major cities are affected by systems that can't get back into service right away. And it's a big impact. We see it in different places around the world. We saw it in Christchurch. We've seen it in Japan. We've seen it over time in the United States, but maybe less frequent. It's a less frequent kind of occurring event if you talk about seismicity. But it's a big deal in terms of the existence of the city in a broad sense, in terms of using the city. So we're focused on that. We're really trying to take this idea of resilience beyond the building code, right? So inserting these ideas so that they can be built, that we can convince owners to do this, and thinking about the life of buildings, and perhaps moving things along in terms of the impact on society, so others will see the value of this.
Mm-hmm.
So
I guess it becomes a question also when you're talking about wanting to design buildings to have a longer life and to perform better over a longer period of time.
Right.
Seismicity could really torpedo some good efforts in that field if you don't consider over the long scale what could happen, I guess.
Yeah, exactly. And it's not just the structure, right? It's all the building systems. And it's for what you don't expect is going to cause the greatest impact on your design. So the what-if scenario is really important. And one of the things that we've been thinking about and developing, and I think the community has looked at this at large in terms of the engineering architectural community, is the idea of structures behaving more like mechanical elements, mechanical systems, rather than static systems. So if you're able to think about buildings in a way that act in a natural way in an earthquake, where joints may move at some point and then stop moving at another point, that's very important in terms of resilience and protecting investment. And it's a long road, right? Because it's a different approach to construction, maybe investment. Maybe there is a premium on the upside of the project, but if we look at the project over a period of time, it makes a lot of sense. So I think for designers, I think that our responsibility is growing beyond just the design of good buildings. It's how do we get everybody else engaged, the contractor, the owner, in a way that it makes sense to do this. It could be environmental issues, it could be business interruption issues, it could be protecting investment over time. Yeah. So those are, but it's up to us to make sure we have a convincing argument that it makes sense to do it.
It's interesting to think about a building not being a static system, although of course that's been a little bit of structural engineering for pretty much forever, right? Dealing with wind, having a little bit of
Absolutely.
But I wonder, that must be so complicated, right? To have to think about all the things that could happen and, like you said, consider what wouldn't happen and then crystallize that into, or consider things that you never couldn't envision happening.
Right.
Then crystallize that all into
Right.
something that you can actually act on. And I imagine maybe things like building information management systems helps.
Oh yeah, definitely.
But how do you even deal with that
Well,
level of complexity?
first of all, it's trying to create a simplified system. So understanding in terms of structure, understanding load path, clear definition of load path. So if you understand where the forces are, you can manage them in a better way. So if you make buildings overly complicated, it's hard to find where forces flow, right? So the first step is simplicity and clarity of systems. And then once you understand that, you take away a lot of the uncertainty in terms of performance, and then you can sort of get at, well, if I'm going to protect the structure in a way, I'm going to fuse the joints, for instance, within my building in a sequential way. I know where the highest demands are, so that's going to fuse first. And when I say fuse, it means dissipate energy. And right now, when we design a lot of our buildings, the dissipation of energy is through permanent deformation of material. So later on, the building's safe, but later on you have to go in there and take it out, and you have to perhaps take the building down because it can't go back into service. So
that's wear and tear you're talking about. Right?
Yeah, but this is, it gets hit with an extreme event, and it's safe, but then what do we do with the building in the end? And a lot of it is in the seismic world. You're right, buildings have been designed, they have to be designed to move in the wind. And then the question is, can we push that limit, right? Can we allow buildings to move even more in the wind? And then when they move too much, maybe there's an active way to control those buildings, right? So there's an imposed system that now changes the behavior. One of the things that we've been thinking about when you talk about the environment, we've been thinking a lot about how do we design buildings that are absent or are released from their dependency on other systems. So for instance, we design tall buildings right now, I'll call it an umbilical cord that ties that building to other systems. But imagine that it was self-sustaining, right? And whether it's energy or it's water management or it's waste, those are the kinds of things that make a lot of sense when you talk about sustainable cities. And how soon we get there is hard to see. I think a lot of it has to do with stored energy. If we're able to store energy, and I think that's a big thing because you talk about solar and those sorts of things, but it's the storage of energy at the time where you don't have that exposure, right? And I think
things like grid batteries or storing that in.
Yeah, and I think I think battery technology it's advancing, right? I think it's advancing probably faster than we know, and I think that whether we call it batteries or we call it systems that are much smarter in terms of the storage and use of energy, I think is something that's going to free us of a lot of these dependencies, So anyway, I think it's part of the overall the overall consideration.
Well, speaking of being free of kind of a weight in a sense, what should we do with the huge glut of outmoded buildings that we have from mostly the 60s and 70s? It's one question about developing a new smart structure and a new smart city, but every city has this huge
what do we do about the building stock? Yeah.
building stock.
Well, I think that's I hate to say it, but a lot of times, at least at the moment, it's a case-by-case kind of scenario. And I think a lot of it has to do with safety. Number one, is the building safe for various reasons. We learn more every time we have an earthquake. We learn more about performance. We learn more about systems, and is the building going to be safe? And if it's not going to be safe, we have this issue all over the world. What to do with that building? And can we fix it? Okay, what does it take to do that, or should we just start over? My argument is that we should be geared and thinking toward reuse, right? So the more we have to build and take away, I think the bigger impact you have on the environment and disruption of business and so forth. So if we can come up with ideas that allow us to look at the future in a way that perhaps components can be removed and reinserted, gravity's gravity, right? When we talk about building, I mean, unless something really changes, we got to deal with it. But when we think about imposed events, they're going to change. I don't know. I mean, winds, they're going to change over time, and it's hard. And it may not be the next 25 years, but it's coming. And I think the more that the building community can think about what if we have to make these changes, maybe our buildings don't look different than they do today. I don't know. Whether it's components or systems that can be easily removed and replaced, or upgraded as we go along, instead of just reacting. I mean, what we do now is we say, okay, we've learned more, and we sort of react, and then we fix or we tear down, right? So these are the things that I think that are important to think about going forward. And it's not easy because these are things that haven't happened yet, right?
Right.
So
to perceive them.
Yeah.
When you talk about things being easily replaceable, is modular construction an important trend in that sense? I
think it's worth considering. I think that you're starting to see a lot of it. The quality control can be better. The time for construction can be reduced, and in fact, you're thinking of it more as a true product than maybe we have had in the past. And I think that it comes from anything from insertion of components within the building to the structure itself, right? Structural steel in many ways is an example of a prefabricated product, right? It's made, the idea is erected quickly in place, but then we get bogged down with other things like diaphragm slabs that get cast, or exterior walls that come in certain, maybe smaller pieces than they need to, and that sort of thing. So I think there's a great future there. The future of that in many places around the world is tied to performance. So seismic performance is tricky. You've got to make sure that those components are properly connected. So wood, for instance, great opportunity for wood. And you could think of it as a prefabricated element, but you've got to connect it in a way that's smart, especially in areas of high seismicity, and I think we're making progress there. So definitely a great place for advancement and ideas, and it brings everyone together. It's not just design, it's contractors and owners. But I think we've got a ways to go there. I think there's some great examples in China, actually, of this. Tall buildings that are erected very quickly. There are a few of them to date. I think there are going to be more.
Which buildings?
Well, there's there's a building that's outside of Shanghai. I haven't visited yet. It's a hotel. It's about, I don't want to be sort of held to this, but it's nominally a 25-story building that was built very quickly, and all components thought of in advance. I think that if you go back in time, Sears is a kind of an example of a product, right? That was a modular system of the structure, and it was built very relatively quickly, and big components bolted together in a very regular way to create, a bundled tube. And I think there's more work to be done for sure, and when we think about the whole system, and it gets into other things like city and infrastructure and this sort of stuff as well. Yeah.
And you worked on this building, right? The Jin Mao?
I did, yeah. Yeah, I spent
now that we're here
5 or so years working on this building, yeah.
Any thoughts coming back to it?
Yeah, I love coming back here. I mean, it's Jin Mao was a great opportunity on many fronts. The idea of bringing some really high science together between design and construction, and the repetitive use of materials. And I think what it did is it sort of blazed the trail, or created opportunities for a lot of other very ambitious projects, not just in China, but all around the world, in terms of whether it was mixing materials, meaning concrete and steel, to exterior wall elements that could be produced not just in Europe, but here in China, to finished materials that have the level of craft that that I think are appropriate for these very important buildings. And the idea of embracing new ideas, new science, and we did that on this project. We were able to mix materials for one. We were able to deal with lateral systems that were unusual and use basic physics in many ways, tying this big core of this building, which you can see very well in the hotel, to the outer large columns at the perimeter of the building, and deal with very unusual site conditions. Very, very soft material for structures to sit on, and a lot of water being next to the Wangpu River, and the idea that these big buildings can actually be done with very deep foundations and construction technology that allows us to move materials vertically very quickly, and making the building cost effective. And I think successful. In the long run, it's important that the buildings are occupied and used, and I think that's a good. Jin Mao has got a very good, I think, track record and example of building use. Yeah, whether it's the office or the hotel. So I think that's important.